So now one question we had, so let's review from assignments from this homework. I'll review from homework 9 till homework 11, let's say, and then I'll try and discuss some concepts that thread across these 3 homeworks. So one aspect is the following. So I had asked this question: X is normal 0, 1. I hadn't asked this particular question, but along these lines. Suppose Y was equal to 3x plus 4. Can you find the distribution of Y? What is the distribution of Y? Answer this question. See. Just try and see if you can answer the question and see if I will try and answer it in a second. Can anybody on chat let me know what they think the answer is? Anybody on chat? On the meeting, can you answer the question? So how would you do this? So first is X is normal. So let me add the solution down. So let's say solution. So the first step is to identify the density function of X, right? So we know that the X has, make it black. X has the probability density function given by the standard normal, right? So f sub x at the point x is e to the minus x squared by 2 over root 2 pi for x in the real number. This is what the density function of x. So now to identify the distribution of y, we need to find the density function of y. So how do you find the density function of y? Typically, if you have a transformation, this is kind of useful to understand. You go ahead and first find the distribution function for y, right? So what you do is you find out, step 1 is to find, this may be an overkill for the linear transformation, but typically you always go and find the distribution function of y as the first step. So what does that mean? That means you have to find the chance that y is less than equal to. So what is that equal to? Y is the same as 3x plus 4. So 3x plus 4 is less than equal to 1. That's what y is. Now, that's going to be equal to the probability that, so 3x plus 4 less than equal to y is the same as x is less than equal to y minus 4 by 2. Right. But what do we know about this random variable x? X has density f sub x, right? So let me just move this across so that I can write more space. I'll come here. Now this is the same as, if I replace density of x, that's just minus infinity to y minus 4 by 3 f sub x at x dx. Right. But now, of course, one can rush and try to find the complete distribution function of y, but I will leave it like this. I will leave it as minus infinity to y minus 4 by 3, and inside I write e to the minus x squared by 2 over root 2 pi dx. So I don't want to complete it. I will just leave it at this time. This is the expression I leave. Sometimes it's useful to find the complete distribution function, but sometimes it's useful to leave it at this stage. The next step you do is, once you do this step, the next step is to find the density function. So find the probability. So here what happens? Here you differentiate f of y. So that is obtained by look at f sub y at y. You differentiate it, and that's what's going to give you the density function of y. Can someone differentiate the above and on chat and let me know what they get, what answer they'll get? What is the density of y? Or what is the distribution of y? Can someone tell me on chat after the distribution? Anybody? Can someone differentiate the top and let them know? Because this is f sub y, right? This is f sub y. F sub y at y is this. So I differentiate this person right here to get the density. Anybody on chat who can answer the question? Okay, so how do one differentiate this now? Let me use the fundamental theorem of calculus. So you know that f by 2 over root 2. And that's what the density is. So now this implies the derivative, that is the density function at y, is d by dy of f sub y at the point y. But what is d by dy of this integral? For the fundamental calculus, what you do is, let's say, apply what's called the fundamental theorem of integral calculus. So look, I don't have just y here, I have y minus 4 by 3. So it's going to be equal to, all I do is I plug in the integrand, that is y minus 4 by 3, the whole squared, times 2, as 1/2 is outside, that remains there. Very good. Then I put down e to the minus 1/2 pi. I do this, right? And then I have root 2 pi at the bottom. Then I have to differentiate d by dy of y minus 4 by 3. And what's that going to give you? That's going to give you e to the minus 1/2 of y minus 4 whole squared by 9, whole thing divided by root 2 pi. And this derivative will give you 1 over 3. It's 1 over 3. Okay. So that's the density of function of y. So from this, can someone tell us what on chat, what is the distribution of y? Can someone on chat say? Anybody on chat? Can someone on chat say? Anybody has any ideas what they'll think the distribution of y is going to be? If y has density this, what the distribution of y? So if I want to write y is distributed as, what will I write here? Anybody can on chat can say? Very good. Normal with mean 0, mean 4, and variance is 9, right? Because you're right. It's like the 3 is confusing. It's 3. Sigma is 3. Sigma squared is 9. So very good. So it's normal. the mean is 4 because that's what exactly it is, right? This mean is 4. Mean is 4. That's how you shift it by, right? So mean is 4, and the variance is just is bottom. So you can think of it from here. That's what you should put. Sigma squared is what you should put in the thing, or you can think of it in here. This sigma is 3, so the variance is just 9. So that's less. Very nice. Very good. So this is a sort of a very standard calculation. If you change normal, let me just make it double so you can see it. So if I make the conclusion a little bit here, we come back here. So it's a very standard calculation. Suppose y is 3x plus 4, and you want to find the distribution of y. You find the distribution function of y. You get an expression. Don't do anything more to it. Leave it like this. But if you differentiate it, you'll immediately use the fundamental theorem of calculus to get this expression right here. But from this, you observe that this is going to be equal to y normal 4,9. And the reason why we can do that is that we know that the density of normal with parameter mu and sigma squared. So y is, suppose you have let's say w, random variable w. This is a fact we used, right? If the fact we used was if w was normal with parameters mu and sigma squared, then f sub w, the density function, the PDF of w, is given by f sub w of w is e to the minus 1/2 x minus mu, or w minus mu in this case, w minus mu whole squared divided by 2 sigmas. So sigma squared I've taken out, so half is taken out, divided by 1 over root 2 pi, and I have sigma here, right? So this is for all w. This is a fact we have used, right, to identify this. On the top, we see mu is 4 and sigma is 3. So I mean sigma squared is 9. That's exactly. Very nice. Very good. So it's an important thing in normal random variables to understand these things, right? Because now from this section right here, if you go to this idea that if x is normal 0, 1, so this is something you can do easy exercise now. If x is normal 0, 1 and y is just a normal with so y is equal to, let's say, ax plus b for some a, b, and r, then can someone on chat tell me what the distribution of y will be? Then y is going to be distributed as, if you apply the same rule as this exercise, what will you get? Can someone on chat write down the answer? I did it for 3 and 4. 3 and 4 I got normal 4, 9. Here what will I get? If you have a and b, what will I get? Very good. So just a little bit, this is a small thing. Yeah, very good. So it's just normal. So what happens is that if I scale the normal by a, right, and I shift it by b, right? Okay. So what will happen is the mean will shift. The mean will go to b, right? And the variance will square. That is normal 0, 1, I should say. Sorry about that. Normal 0, 1. Maybe I'll leave the mean as, it's okay. So the mean will shift by b, and the variance will shift by a square. Then multiply by square. Right? This is akin to the calculation that the expectation is linear, right? So e of ax plus b is equal to a times e of x plus b, and the variance of ax plus b is equal to a squared times variance of x. So that also tells you indication that the variance will scale by squared, and the mean will just shift by b. Because here the mean is 0, so the mean shifts by. Very nice. That's one question to understand. I thought I'll review this question on homework 9.